Next, we analyze the step response of the PD compensated and also PID compensated system. Okay, so how to do that? We just write the KPD, means the gain for PD that we get from the root locus actually. Okay, so from this one, we can get the transfer function of the closed loop transfer function, which means we have to solve for feedback system. So we use the Matlab command feedback. KPD means the gain times the transfer function of the PD. So we get the transfer function. And next is to get the closed loop transfer function for PID. So first we get the gain for PID from the root locus of the PID controller compensated system. And after that, we get the closed loop transfer function with feedback Matlab coding, and we get the transfer function for the PID. So then we plot the step response at figure 4. We use step, and we want the step response of GPD closed loop and also GPID closed loop. So after when this is the figure display the PID. So the green color is the PID closed loop and the blue color is the PD. Okay, so the results here shows the apparent positive effect of the integrator in the PID controller. Okay, so this is the PD and this is a PID. So it shows a positive effect. Okay, the steady state error previously obvious on the PD compensated, but it has been eliminated when we compensate the system with PID, and also the peak time recorded was close to the theoretical value of 0.23 seconds. So for this peak time is recorded as 0.26, which is close to the theoretical value. So that's all for design controller using root locus via Matlab.